far, we have learned how to get rid of parentheses. Let's say we have something that looks like this. We know how to get rid of parentheses. We distribute, right? Now we're learning how to get rid of fractions in an equation. So let's say you have a problem that looks like this. This has a fraction here, and then a whole number here. So in order to solve this, we need to put a 1 under all of the numbers that are in a fraction. So we need to put a 1 under all of the numbers that are in a fraction. And that's what we did right here. So we have this one. Now we have a fraction here, and a fraction here. Now we're set to continue. Now we need to find what the GCF is. What is the GCF? The GCF is the greatest or the biggest number that you can divide by all of the denominators. So they're talking about the greatest number that you can divide. Division is the operation by all of the denominators. Remember, the denominator is the number in the bottom of the fraction. So I look over here and I see that my denominators are 4, 2, and 1. I'm looking for the biggest number that I can divide by all of the denominators. So here I have 4. Divided by 4 is going to give me 1. 4 is the GCF. Divided by 2 is going to give me 2 for the second fraction. 4 divided by 1 is going to give me 4 for the last fraction. So these green numbers here, I am going to put in parentheses underneath the equation, like this. Let me double check my work. If I do 1 times 4, I get 4, right? Which is the GCF, yes. If I do 2 times 2, I get 4, which is the GCF, right? Yes. If I do 4 times 1, I get 4, which is the GCF, right? Yes. So now I know that I have found my magical numbers that go on the bottom. I move down here. I took the green numbers from up top and I put them underneath the fraction they go with. Now I need to multiply the number underneath in parentheses by the numerator. Remember, the numerator is the number on the top of the fraction. I multiply through here. 1 times x goes here. 2 times 3 goes here. 4 times 10 goes here. If you notice, the fraction is gone now. It's magic. This is how we get rid of fractions. I am left with, I distribute. I am left with this equation here, and we know how to solve this one. Easy, 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 right? I draw the line, minus 6, x equals 34. I know that was a lot of language and a lot of steps, so let's just try to do it here. These are the first 3 questions on the pages that you have to do for classwork today. So just look at them here. We have 1, 2, and 3. So the first thing we want to do when we look at number 1 is put the number that is not a fraction over 1. Now I have 3 denominators. What is the GCF, or the greatest common factor of these 3 numbers? It's going to be 6, right? Because I can multiply 6 by 1, 3 by 2. Oh, I don't know why this is, hold on. Hold on. Okay. I can multiply 6. Why does this keep doing this? So I can put 1 down here, 2 down here, and 6 down here. If I multiply 6 times 1, I get 6. If I multiply 2 times 3, I get 6. If I multiply 6 times 1, I get 6. 6 is the GCF. Now I multiply the numerator by the green number below. And I get 1 times x plus 2 times 2x equals 6 times 5. And now I just simplify. I get x plus 4x equals 30. I combine my like terms, I draw the line, and I get 5x equals 30. Divide both sides by 5. X equals 6. Let's try this next one here. Make sure that you copy down this work. That way when you go home and do your homework, you have something to look at if you get stuck. So number 2. First, we put all the numbers over 1. And now we try to find the GCF. So I can't divide 3 by 2. So the GCF here would have to be 6. So I'm trying to find the numbers that I multiply the denominators by to get 6. So I put 2 here, 3 here, and 6 here. And now I multiply the numbers below times the numerators. I get 2x plus 3x equals 6. I combine my like terms. I get 5x equals 6. I draw my line, divide by 5. X equals 6 divided by 5. Let's do this one here. I want you to pause the video, do this one on your own, and then when you unpause the video, check your work. Did you get the same work as this? Good, you should have. So if you'll notice, in all of these problems here, we have a fraction, some sort of operation here, a fraction, equal sign, and then another answer here. So we have an equation. What happens when there's no other fraction, no operation, and we just have a fraction equals a fraction? When we have a fraction equals a fraction, we call that a proportion. So when it's just one fraction equals one other fraction, it's called a proportion. So now let's begin solving these proportions. So here we do the same thing as we did with the fractions before, except the number you use is always just going to be the one on the other side. And then I multiply the number down here times the numerator. So here I would get 40 equals 8K. Now it's very easy to solve, right? Okay. Let's try this one. So I bring this number here, I get 3. Oh, wait. I have a better GCF, don't I? That's going to be less work and smaller numbers. Instead, let's make the GCF 12 here, and we'll just put these numbers down here. Now, we're still going to have a GCF of 12. We're just working with smaller numbers. So now, we multiply the bottom by the top, and we get M equals 7 times 4 is 28. That's much easier, right? Let's do this one. Here, I have 2 divided by x equals 7 divided by 9. In this case, there is no common GCF, so I just put this number over here, this number over here. I get, when I multiply, 18 equals 7x. X equals 18 over 7. So now let's try this one. Do this one on your own, pause the video, and then check your work when you unpause the video. You should have found the GCF to be 12, so you multiply this one by 1, this one by 6, and you get x equals 60. Now, does our answer make sense? How can we test to see if our answer makes sense? We can substitute this value in for x and see if our answer is true. Let's see. 60 divided by 12 is 5. 10 divided by 2 is 5. Our answer makes sense. We're going to make a connection with what we learned on Friday about no solution in all real numbers. Remember, if we got 5 equals 5, it meant that this equation was true for all real numbers. So if we find 5 equals 5 on either side, this equation is true. That could be very confusing. Just go with it for now. For classwork, you're going to finish this page. And then for homework, you're going to finish this page. On Tuesday, I'm going to check both pages as your homework. And then on Tuesday, we also have an excellent project that we're going to start. It's going to be really fun. You're going to make your own videos. So get excited for that.